Just a smidge. I mean, I like donuts and all. But
a limited amount.
Well, yeah, right. Eventually you get sick. So, that project, on a scale of 1 to 10, 10 I loved it, 1 I hated it.
10.
On a scale of 1 to 10, 10 unbelievable amount of effort. I can't believe you made that a project. That should have been a final exam. 1, I could have done that in 5 minutes.
1.
Okay, see that's okay. Good data. I tried being collecting that more. I keep hearing that more and more from students that almost seems like it should have been a quiz than a project.
Yeah.
Yes. And again, I just started hearing that over the past couple terms with this one. I think I like to think I can't prove this or disprove it, that it's because I get you guys in Excel so much that when you do open Excel, it's like duh. Whereas my first batch of students were like, what the hell? How do you open a spreadsheet? So
Yeah.
good to know. Good to know. What was the point of it?
The 95%.
Good. Give me more. Give me more. Caitlin, go ahead. What do you need? 95% confidence.
What it really means.
Thank you. Means with the quotes. Good. So what I'd like to do real quick to drive this point home, I hate to say once and for all, but I'm going to say once and for all because I think with this kind of being the final like tack in the building or the room that is the idea of confidence, you can actually see it now. Because we talk about it all the time. What does 95% confidence mean? Well, it means if you run a trial 100 times, in 95% of those trials, you're going to do what you think you're doing. And in 5% of the time, you're going to miss it. What I want to do right now is I want to link all of your guys' results together. Do you remember when you ran your data, on that project, what percent confidence you yourself got? Did anybody get as low as 85% or below 80? We got 80? 80. Okay, anybody get below 80? Good. Let's come back to that. So we got an 80. Nobody got an 85? We got an 85. Anybody get a 90? We got a 1, 2, 3, 4 90s? Oops, 90. Excuse me, I should be keeping track of this too. Was 5 90s? 5 90s. Anybody get 95 exactly? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 95s. And anybody get 100? 1, 2, 3, 4, 5, 6. All right. So here's the distribution of what you guys saw, what you guys got. Now Naomi got an 80. So she's thinking, what the hell? 80. But again, you almost have to think of this. I'm going to turn this off for 1 second and untangle this cord. You almost have to think of this as geologic time. Outliers happen, yes?
Yeah.
Outliers happen. That's kind of why they're called outliers, because they do happen. They just don't happen often. That's what makes them outliers, right? I mean, otherwise they're just a large or a small data point. So now, here's our data right now. What I'm going to do is I'm going to run one of our stats on it. Okay, one of our stats on L5 and L6. Please notice, friends, what the average confidence you guys achieved was. 94.5%. And some of you would say we shouldn't even use the average in this case because you had the wicked little 80 outlier down there, so you might want to use the median instead. So I can scroll down to the median if you want to look at the median, and the median happens to be exactly 95. So this is the point, right? And this is the final kind of like, okay, I get it now. And I love what Caitlin said, to include what the 95 means. That's what it means. It means on average or on typically, you're going to hit it 95% of the time. Yes, you have to accept the outliers. Sometimes you'll miss. This is why we do what with studies? This is why we replicate them. This is why we replicate them. So the outlier, if it is an outlier, won't be outlier's choice. Remember the logic behind replicating a study and hopefully preventing outliers? Let me phrase a question for you. What's the chance of an outlier as we've defined it in this class?
5%.
Right, 5%. That's why our p-values are always compared to 5%. That's the chance of an outlier. What's the chance of 2 independent successive outliers in 2 studies?
0.25.
No, 2.
Why 0.25%, yes? 1 in 400. Good. 0.2. Now 0.25 is 25%. Holy crap, no. We don't have to go up, we have to go down. So how did Blake get 0.25%? Kendra? Because if the chance of an outlier is 1 in 20, the chance of 2 independent outliers where the study is done exactly the same, replicated exactly the same, is 1 in 20 squared, which becomes 1 in 400, which is 0.25%. Fair. That's crucial. And do it a third time, right? Do it a third time. On the off chance you get 2 outliers, the chance of 3 outliers is then exponentially even smaller. At that point you have to go, holy crap, maybe they're not outliers. Maybe we're actually seeing some new behavior. That's the point, yes? That is the point of replication. Fair? Good. I have to emphasize, as Veronica has done before, the study needs to be done exactly the same in order to call replication. If you make the same bias errors in the new study that you made in the first one, you're going to get predictable weird results that are based on sampling, or maybe non-sampling, but maybe sampling error. So, again, it's outside the scope of this course, the whole idea of setting up studies and getting things like that done, but it's worth mentioning, as it always is. That's one of the reasons I like talking about the error analysis on that template sheet. Ooh, FYI, I made more copies. Anybody need more copies of the template? I'll leave them here for you. Who needed data sheets? I made a few more copies of the data sheets, the new ones that we're doing now in class. Nobody needs them? Okay, I'll leave them here too if you need them. In case you can't find it in your bag. I made those in color too, because I was feeling saucy. I had a thought there, it was gone. Yeah, anyway, I wanted to make a nod to what Veronica said again about the replicating study exactly, otherwise it's meaningless. But I love talking about the error types, because Linda just brought up a very good thing about the I don't know. This 5% is still kind of vacuous, it's still kind of floating around. And I want to harp on that 5%. That 5% is simply something that industry has, and practice has put in front of us and said we are going to use this number. We've talked about the times you want to lower confidence maybe. So that 95% confidence goes with 5%, what's called significance. But as you know, as confidence goes up, as we apply the Carley principle to it, as confidence goes up, type 1 error goes down, but type 2 error, which is called beta, goes up. I put a quiz up next week for you guys to explore that if you want to. There's 2 quizzes next week, if you want to do either of them. One is simply an exploration of that idea of type 1 and type 2 error and how they change. I got a question for Blake in there too, so based on what you said a couple days ago. Thought you guys. So that's one quiz. That does not need a template sheet. The other quiz, if you want to do the other one, is going to need a template sheet. And pretty much every quiz from now on that you have to run a hypothesis test on, you're going to want to have a template sheet to turn it on. So just when you submit it, just put your name on the top and tell me which quiz it is, because sometimes you might be turning in 2 at once, and all the sheets look the same. So just make sure I know which one you're doing. I mean, I can tell probably from the content on it, but just so it's easy, make sure your name's on it for sure. That's the best thing, so I can give you credit for it. That's it next week, right? Just a couple quizzes. Hello. Yes. Okay, good. That was a lot of information. What questions do you guys have? Or did I just make more? I apologize if I did. Maybe I did. Good? Good so far? I want to come back to Linda's 5%. That 5% is somewhat arbitrary, handed down to us by industry. We've talked before, like Carley, with the confidence. You can change confidence. You basically have that choice. You can adjust what confidence you want, because that confidence lives on the well, you know what, let's not talk, let's do. Did you guys give the show